natural log v plus c. But what's v? Sine inverse of u. But what's u? X squared. So you'd wind up getting the same exact answer. Two substitutions. All right, good. All right, I'm going to go with another volunteer here in just a second, but unless the volunteer wants something weird, really weird. Anyone want to volunteer for a really weird one? Okay, good. What do y'all think? I mean, if this is your first time seeing substitution, I mean, what do y'all think about this so far? Ow. Really? Okay.
It's kind of like when you first started doing trig. You just kind of have to, if you know certain things, you can just kind of, it's easier to see a pattern.
Yeah. All right. How about this? X plus 8? Why? What? Because it's inside the parentheses? So you just want to make that u? Okay. Do you see its derivative there? What's the derivative of x plus 8? It's just 1 or just dx, right? So you see it there, right? You'll see the derivative of this is just 1 dx, or just dx, and there it is. So I'm going to go with this, but before I do it, let me just remind everyone as to why we can't just use power rule here. We can't force that x through, right? Can't do that. Now we could expand this. We could do x plus 8 times x plus 8 times x plus 8 400 times. We would get this huge polynomial, right? And then we could multiply x through, and then we could do them term by term. No way, right? We don't have enough time for that. So let's just see if this works. U is equal to x plus 8. What's du? Dx. So,
like the same thing, solve for 8, so use u minus 8 to do x.
exactly. So that's what I wanted everyone to see. Yes, this is going to be replaced with u, right? Dx is going to be replaced with du, but the x needs to be replaced. So let's replace that with x is equal to u minus 8. Yeah? Solve that for x, and you get this. Rewrite the problem. What do we have? U minus 8 here in parentheses. X plus 8 to the 400th is now what? U to the 400th, and dx is du. Did we gain any ground here? Why is this expression okay to work with when this one wasn't? Now you can multiply u to the 400th through, right? You can pass that through now. And so you get integral u to the 401st power minus 8 u to the 400th power du. And you can do those term by term, right? Each one separately. You could? No? So let's finish it up. Antiderivative time. 1 over 402 u to the 402 minus 8 over 401 u to the 401 plus c. That's just power rule. Yes, there's some ugly numbers, but that's what it is, right? Replace all your u's with x plus 8's in parentheses, right? And you're done. That wasn't so bad. The reason why that one wasn't so bad was because we saw this earlier, this little solving thing. We saw that earlier. It would be a lot worse had we not dealt with that earlier. All right. Who's my next volunteer? What's your name again? Crystal? Did I skip someone? No? All right. Crystal. Oh, there you are, with a K. All right, Crystal, do you want to pick one off that sheet, or do you want me to make one up? Doesn't matter? Okay. Before Crystal does this one, I'm just going to let everybody know, when you're doing this, what we call basic U substitution, don't ever make the substitution U as X. Did I tell you all that last class? No? I don't think I did. Don't ever make that substitution. Because if you do, all that's going to happen is you're going to rewrite the integral, except everywhere you see an X, there's going to be a U. So it's going to be the same exact problem, just with U's instead of X's. So this is never a good substitution. You've got to grab more than just X. All right, Crystal, any ideas? X.
X plus 5.
You just want to go with X plus 5? Yeah, okay. Now, are you doing that more out of just like, I've got to try something? I may as well try that?
Well, I was thinking, like, it's squared on the bottom.
Mm-hmm.
Like, if you flip it to the top kind of thing, then you have it in there.
So if you do that, right, this is going to become U squared on the bottom. That's good, right? You just got to figure out what to do with the top. So let's see. Let's keep going. This is going to be du equals what? 1. So we always just put dx. Don't forget that, okay? Because we're trying to replace things. We need dx here, not 1. All right, so I'll be able to replace this here with du, this right here with u. How about x minus 4? You've done this now. This is what you told me to do last time, so what?
Move everything over.
Solve this for x, and you get u minus 5.
That's not 4.
It's okay. Just go replace that x with this. All right, so let's see what we would have. X, which you're saying is u minus 5, minus 4 over, yeah? What's the bottom? U squared. And what's dx? du. Clean up the numerator. What do you have? U minus 9 over u squared du. Any ideas, Crystal?
Do you still move the u up, like to negative?
You move the u up as u negative 2? You could do that. You'll get to the same place that I would get if you...
Or do you want us to sub out the u again, like do it twice?
No, I don't want you to make it more complicated than it has to be. You can bring the u squared up. But how many terms do you have now in the denominator? 1. And 2 on top? Can you just split that up into 2?
Yeah.
Yes? So you would have, what? This, no, this over this, right? Minus this over this. So split it into 2 fractions.
U squared minus 9 over u.
So u over u squared minus 9 over u squared du. And then clean those up. U over u squared is 1 over u. And right there, when you see 1 over u, you should be thinking, bang, natural log. You should be thinking that right away now, okay? And then this one over here, that's not natural log, right? So this one I'll write 9u to the negative 2 du. So this one I'm going to need power rule on. This one I'm going to use the special property. Yeah? All right. I'm almost there. Equals antiderivative of 1 over u is ln absolute value u. And then what's that going to be? Plus 9u to the negative 1 power. Yep. So look, when we start doing these power rules now, I'm really going to stop showing any detail. And I think I was trying to get you to see that last class. Like, as we progress, right, the next time that we meet, I'm going to expect that you've got substitution down. Because when we do problems later, if we do a substitution, I may not go through all these details. I may say, oh, you see this problem? Oh, well, we could just do a substitution and get to this. And that would be something that you would need to be able to do on your own. So everything is kind of like piling on top of everything here. Yeah? Okay. Let's just replace u. Natural log x plus 5 plus 9 over x plus 5, because I just didn't feel like leaving it to the negative 1 power, so I dropped it all down. There's your antiderivative. Good. Now time is starting to become an issue. I'm making one up. Anybody want it? No, you know what? Forget that. I'm calling on someone. All right, let me do it this way. Okay. Someone, first person who shouts out a number between 1 and 4. Come on, give me 3. Okay, my third finger here. This is Austin. All right, Austin, you're up. Hey, but you're off the hook. You don't have to worry about getting called on next class. All right, let's give Austin an opportunity to think for a minute. Time's up. No, go ahead. I'm kidding.
Would be e to the 2x.
Okay, let me try. You want that as you? All right. All right, so if this is e to the 2x, right, then the derivative of this will be itself, right, e to the 2x, but chain rule would require derivative up here, 2, so that would come here, and then I tack that dx on. So Austin, is that going to work for us? Do you see this derivative somewhere? You're going to replace this right here with u, right? So the only thing left to look at is the stuff that my hand's not covering. Do you see this there anywhere?
I don't know if you'd be able to rearrange it to make it look like the top.
So what's the problem? What's the issue here?
2x.
The 2x is the issue. Yes, I agree. And you are not going to be able to turn this into this. So what do you do in this case, Austin? You start over, and you pick another u. So we're still going to let Austin do this. I